online tutorial class where physics is brought at your doorstep. Now today we want to study physics again. In our last class we talked about surface tension, that is fluid at rest and in motion. Remember, we defined surface tension as the force acting along the surface of a liquid, causing the liquid surface to behave like a stretched elastic skein. We equally define it as the force per unit length acting at right angle to one side of a line drawn in a liquid surface. We equally define it as the work done per unit increase in the surface of a liquid. And remember, we talked about the unit of surface tension, which we say it is measured in Newton per meter or Joule per meter square. Remember, we equally talked about the effect of surface tension. We talked about the applications of surface tension, and we equally talked about the method by which the surface tension of a liquid can be reduced. Now today we want to look at capillarity. Let's say it's capillarity. Again, capillarity. Now we go over to our specific objective. Now by the end of the lesson, students will be able to, number one, define capillarity. Two, differentiate between cohesion and adhesion. Thirdly, state the applications of capillarity. Now, we find out that when tubes with fine bores of different diameters are immersed in the tray of water, you observe that the water rises differently in the tubes, and the narrower the tube, the greater the height to which the water rises. Now, if the water is replaced with a soap water, you observe that the rise in the liquid level in both the tubes is not as high as when it was in water. Now, if that water is replaced with mercury, there will be a decrease in the level of the liquid in that tube. What do we mean? Now you find out that when you have a fine bore or bores with different diameters, as you can see in this diagram, you have a beaker of water and you have a beaker containing what? Mercury. Now we are talking about the rise in the level of liquid in a tube. Now you look at this tube. This tube is the narrow tube. The narrow tube. Look at the water level, the rise in the water level in the narrow tube. When you immerse it in this beaker of water, the level of water rises higher than when you have the diameter of this tube more than the narrower one. Now look at the diameter of this. Look at this. This one, the diameter is higher than this, followed by this. So this is the narrowest. You see the level of water when you immerse the three tubes. Water rises higher at this narrower tube, followed by this other one, and the last one. Now you look at mercury. Now for mercury, look at the tube with the narrowest, followed by others. You find out that there is a decrease or a depression in the level of what? Mercury rise in the tube. Now look at this. Here I have three beakers, immersed tubes of the same diameter. In the first beaker I have pure water. In the second beaker I have soap water. And in the third beaker I have what? Mercury. Now look at the level of water rise. In the first beaker, the pure water rises at a higher level in this tube. Now look at the second one where you have a soap water. There is a rise also but it's not as high as the first one where you have pure water. Now look at mercury, the beaker with mercury. There is a depression in the mercury level. Now, what do we mean by this term, capillarity? What do we mean by the term capillarity? Now, we define capillarity as the tendency of a liquid to rise in a narrow tube or in a capillary tube. Let's define it again. It said that capillarity is the tendency of a liquid to rise in a narrow tube. Now, whether a liquid rises or whether it is depressed in a narrow tube or at the edge of a glass container, it depends on the relative strength of the cohesive force between the molecules of the liquid and the adhesive forces between the molecules of the liquid and those of the container. Now, what are we talking about? That the rise in the level of a liquid in a container depends on two forces: the force of adhesion and the force of what? Cohesion between the molecules of the liquid and that of the container. Between the molecules of the liquid and that of the container. Now, let's see what do we mean by this force of cohesion and force of what? Adhesion. Where we say that the rise in the level of liquid depends on these forces. What do we mean by this force of cohesion and force of adhesion? Now, cohesion or force of cohesion is the force between the same type of molecules, while adhesion is the force between two different types of what? Molecule. Now, when you have the same type of molecule, the force that do exist there is the force of what? Cohesion. For example, mercury. Now, if you have different types of molecule like your water, that is H2O, 2 atoms of hydrogen and 1 atom of oxygen, the force between them is the force of what? Adhesion. That is the force that brought the molecules together. Now, water molecules, they are more strongly attached to glass molecules than they are to other water molecules. You find out that water tends to cling at the walls of the container, at the walls of the glass, and that is why water normally have what we call, in water you have what we call concave what? Minuscules. Water do form concave what? Minuscules, because it has the ability to cling at the walls of the container. So the adhesive force is greater in water. Now, we say that water molecules are more strongly attached to glass molecules than they are to other water molecules. Thus, adhesive forces are stronger than cohesive forces. So in water, the adhesive forces, they are more stronger than cohesive forces. This results in the rise of water level at the edge of a glass container or in a narrow tube, where water comes into a container, comes in contact with the container or with the glass molecule. Now, what are we talking about here? Now, you find out, as I've said before, that in water molecule, the force of adhesion is higher than the force of what? Cohesion, because water tends to cling at the walls of these glass containers, and as a result of that, we have a rise water level in the container. Water rises higher in the container. Now, we say that a concave minuscule is formed and the minuscule curves upward. So as I've shown you in the diagram, you look at the diagram, because of the rise in the level of this water as a result of stronger force of adhesion, you find out that water forms a concave meniscus. Look at the diagram, concave. You see how it is curved. It forms what? A concave what? Meniscus. They may draw the diagrams in the exam and ask you which one indicates the level of water rise in a container. Please take notes. Water forms what? A concave what? Meniscus. And for water, we say that it has a stronger force of what? Adhesion. Now, the opposite is true for mercury. The cohesive force is stronger than what? The adhesive what? Forces. So you find out that in mercury, the force of cohesion is stronger than the force of what? Adhesion. Thus, mercury is what? Depressed when it touches the edge of a glass what? Container. So when mercury touches the edge of a glass container, there will be a slight depression, a slight fall in the level of what? Mercury. And therefore, mercury forms what we call a convex what? Meniscus. Let's see the diagram. Now you can see mercury in a container. When mercury clings the walls of this container, you find that there is what? A depression in the mercury level. And therefore, mercury forms what we call a convex what? Meniscus. You can see the diagram, how the curve looks like. For mercury, you have a what? Convex what? Meniscus. While for water, you have what? Concave what? Meniscus. Please take note of that. Now, for mercury, we say a convex meniscus is what? Formed. The meniscus curves downward, as I've shown you in the diagram. Why cohesion and adhesion determines whether a liquid rises or falls when it is in contact with a surface. Now, the degree of rise or fall of this liquid depends on what? The surface tension of the liquid. Let's take it again. We say that why cohesion and adhesion determines whether a liquid rises or falls in a container. So the forces that determine the rise or the fall of a liquid in a container are the force of what? Cohesion and what? Adhesion. Then we now say that the degree of rise or fall of this liquid depends on the surface what? Tension of the liquid. Remember, we've talked about surface tension. We say it is the force acting along the surface of the liquid that causes the liquid to behave like what? A stretched elastic what? Skin. Now, the force of cohesion, the force of adhesion, and this surface tension, they are the forces that are responsible for the capillarity of liquids, or they are the forces that are responsible for the capillarity action of the liquid. So when you are being asked to state the forces that are responsible for the capillarity action of a liquid, what are the forces? They are the force of cohesion, which we have explained, the force of adhesion, and also the surface what? Tension. Remember this force of cohesion, the force between the same molecules, for example, mercury, Hg. The force of adhesion, the force between different molecules, for example, water, H2A, and also the surface what? Tension. They are the forces that are responsible for the capillarity action of a liquid. Now, where do we apply this capillarity in our everyday life? Capillarity is being applied. Where do we apply it? Number one, the ability of a lamp wick to absorb the liquid, paraffin or wax from the base of a lamp is due to the capillary action of the what? Liquid paraffin within the fibers of the wick. Now you can find out that the wick of your lantern, for those of us that are using lantern, or the wick of your stove, those of us that are making use of stove. When you put a new wick in your stove and you apply your kerosene, you find out that at the initial stage, when the wick have not absorbed the kerosene, if you put on light on that wick, it will not light up, except when the wick has absorbed the liquid kerosene. So when it has absorbed the liquid kerosene, that is when your wick will give you lights. Now you find out that the ability of this lamp wick to absorb this liquid from the base of the lamp or from the base of your stove is as a result of what? Capillarity. Is due to the capillary action of that liquid within the fibers of the wick. Another application, we apply it in the movement of water from the roots of a plant to the upper part of its stem. Is due to the capillarity of water in the tiny tubes, that is the xylem, in the plant. So you find out that the movement of water from the roots of a plant, water moves from the roots of the plant to the upper parts of the stem, is as a result of what? The capillarity action of the liquid. Another one, the ability of your kitchen towel to absorb spilled liquid is due to what? The capillary action of the liquid within the fabrics of the towel. So you find out that your kitchen towel, when you have any spilled liquid, you use your kitchen towel to do what? To soak it. And that kitchen towel is able to absorb that spilled liquid as a result of the capillarity action of that liquid within the fabrics of the towel. So my dear students, find out that by now you'll be able to define the term capillarity. You'll be able to state what force of cohesion and adhesion is all about. You'll be able to state the forces that are responsible for the capillarity action of liquid. You will equally be able to state the applications of what? Capillarity. Now, evaluation. Number 1, define capillarity. 2, differentiate between cohesion and adhesion. Then 3, state 2 applications of what? Capillarity. Now we come to the end of today's lesson. Thank you for your patient listening. We will see in our next class.